takeaway for me is the importance to recognise the type of construction that you're dealing with, be it block, stone, rendered, unrendered, and particularly if it's rendered and it's rendered internally, is there the presence of gypsum or otherwise? And if gypsum is there internally, you have to proceed with real caution. I think you'd be probably as well to strip the wall back and get rid of the gypsum before you go applying any additional measures internally. Is that what
gypsum's a really high risk surface to inside over,
yeah.
And that goes for any material. So if you're putting anything in front of gypsum, you create cooler temperatures behind your newly installed insulation. So less heat gets to the wall. So in other words, that intersection is colder.
Yeah.
So that becomes the high risk point. And if it's high risk for moisture. And one thing that gypsum does not like is moisture. It has no ability to buffer moisture. It changes in volume really quickly. So if it gets wet, it'll tend to blow and become boast and things like that. And likewise, because it's such a neutral alkalinity, its pH is around 5 or 6. It can't resist that outbreak of mold and things like that. So it's a terrible surface to have back there.
Yeah.
Ideally, you'd have lime, but in some instances, you can have cement and things like that, you know. And likewise, there are certain, I probably didn't mention this, but there are certain surfaces on walls that you'd want to watch out for as well. Certain paints and things like that and wallpapers would need to be removed as well before internally dry lining.
I think this is really topical now with the launch of the National Retrofit Scheme last February.
Mm-hmm.
We're about to embark on retrofitting 500,000 houses between now and 2030. And, you know, there's a lot of those houses that are going to fall within the traditional building.
About 300,000.
Category. So
yeah,
you need to be ultra careful when we're addressing and coming up with a roadmap for these houses.
Absolutely. And I think, as you said before, I think the SCAI are in the process of tailoring some of the grant aid packages for traditional buildings. At the moment, I'm seeing, and I'm sure you guys are seeing too, there's quite a large push towards low U value targets in certain areas, which is fine, and it can be achieved in cases, you know. But I would be wary of some of the IAB certified systems that are being used simply because they have IAB to achieve a grant package of IWI. The risks associated might mean, financially speaking, you'd be worse off because you might be in a situation in 5-10 years where you're pulling out dry lines. Just chasing that small package. So I'd just be aware of it. But yeah, you guys would be far more experienced in that respect than I would be. And to be honest with you, I have a good few friends that are energy assessors, and you know, I draw from their experience all the time. You know, so
and the danger is that you know, one of the overarching requirements for grant purposes at the moment, and there's a massive drive towards heat pump, is the simple HLI calculation. And so, you know, that requires good levels of U values on all elements, walls, floors, roofs, etc. And so if some of those walls then can't achieve those U values due to maybe a traditional construction method, and we're using something like calcitherm, which achieves a U value of about 0.51 or 2, it means you have to overcompensate elsewhere on floors and roofs, etc.
Yeah, absolutely.
Just wondering that is the HLI how relevant is that, or how? You know?
I like that calculation method. I like it a lot because one thing that I've experienced to date is the heat pump assessors working closely with the architects in terms of the thermal specification, so they're less focused on driving it into unrealistic territory or risky territory. They're more focused on satisfying the HLI, which is somewhere where you can meet them in the middle. But the biggest problem I see really is the traditional the traditional buildings that are not replacing the windows really puts pay to the HLI, because a lot of the traditional buildings that we're talking about within that 300,000 housing stock would be, we'll say, mid-terrace townhouses, tall buildings, but not a lot of actual wall facade. So by area weighted proportion, there's not a lot of U value to consider on the walls. It's mainly windows. So if they don't do the windows, it means that you get some ridiculous number put on the wall to overcompensate for the lack of window replacement, etc. So it works in a few different ways. And likewise, people sometimes aren't willing to break up their floor. That's very common. And then that in turn puts stress on other elements within the building. So it really does go back to some of them key documents I showed at the end. One thing that's common, a really common theme in all of those documents, that if you read them enough, you'll see there's a kind of a theme throughout them all, that when you're approaching a historical traditional upgrade, it really needs to be holistic. It needs to be every part together, you know, otherwise you'll see elements kind of going off in a mad direction, you know, and I've experienced that as well.
Okay, there are a number of questions there in the forum, so maybe we'll jump right in there. Is there any plan to change the standard from basic condensation risk analysis to more complex assessments? Like
there is already, yeah. So SR 54, which many of you will be really familiar with, and Part L of the Irish Building Regulations, BS 5250 and 9520, which would be the Code of Practice for Control of Condensation in Buildings. All of those documents, so any document that's relevant in an Irish construction context, already mentions the requirement for EN 15026. And the SEAI themselves and the NSI themselves would largely be supportive of the use of EN 15026, which is the numerical simulation method. Now, this is kind of where it gets a bit contradictory. You're told, all right, to use that to assess the risk, but at the same time, during some grant aid applications, you're still being told U value must be X and you must use something that has this type of cert on it. And that will completely contradict the results of some of those assessments. So what I'd say sometimes is that you're better off being led by the risk than by anything. If you can scientifically prove that something is probably generating a high degree of risk, that's worth avoiding at all costs. But you know, there are cases, of course, where that's not the case. But numerical simulation is widely agreed to be the only way to assess pretty much two of the main building elements, one being flat roofs and one being single leaf solid mass construction. For other elements within the building, the standard dew point assessment method that many of our U value softwares can calculate, that's generally accepted for most other building parts.
Does the external render have to be breathable when using a breathable internal lining system? That's a
good question, actually, because that depends on the condition you find yourself in the first place. If you had plans to render the building, you certainly wouldn't render it in anything the non-breathable, because you won't have gained all the advantages that you could have. If you had to use the breathable render on the outside, you'd have full drying capacity outside and inside. So you'll have a building there that will be very resilient, well into the decades, very resilient. Now, if you had to put a brand new non-breathable plaster on the outside for the first 3 to 5 years or so, that building will be nice and dry. But as the building moves and creaks and groans over time, it lets in bits of moisture, and then that external render becomes a bit problematic over time. So now you're fully relying on the inside to do all your drying. And as we saw earlier, only about half of drying occurs to the inside, so it can be slower, but still not the worst case. You know, if you happen to find a building that already has a render on the outside and you're looking at an IWI approach for the inside, it would be best to just recommend that the condition of the external render, if they're unwilling to remove it and replace it, that is, you know, but if the condition of the external render is poor, the first thing that they need to do is inspect it and to put the building in a weatherproof, defect-free state. Because if they do that, they limit the amount of water that can get into the wall. And that's really the key. And then if you used a breathable insulation system on the inside, you've given that wall the best chance it has to dry out potentially, with the ace in the sleeve always being removal of the external render at a later stage. You know, so it just depends on the expectations of the client in each case. Sometimes they just won't be willing to go that far.
Case by case.
Yeah, and in most cases will be, no, the render's staying. And if that's the case, well, make sure it's well painted and, you know, sealed at sills and windows and things like that, and that your gutters are clear and that your drainage is good. And that'll give the building the best chance it has anyway.
Okay. What is the optimal insulation solution to upgrade walls where periodic features are to be retained, and how costly? I suppose this is really touching on maybe protected structures as well.
Mm-hmm. Yeah, protected structures are kind of unique in a way because they don't have any target values, but they want to be useful and comfortable for the occupant. So there's a couple of different ways in which it's done. I have been involved in some projects where the features were carefully removed they were altered and restored. That was accepted and that was done, and it was really successful. That's rare. Most often the features are not being removed, and you have to work with them as a compromise. A good compromise might be the cornice. If you think about your insulation as a board, say you've lime plastered internal walls with paint on it, okay, and you managed to sand off a lot of the paint with a mechanical festool sander or something like that. Now you could use calcitarm, for example, on that, but you don't want to end up with a square bulkhead beneath the cornice end. It'll visually be terrible looking. So what they'll often do is they'll use a tapered board to taper down into the end of the cornice. And then you'd be asking, well, what about the thermal bridge? The cornice is kind of preventing me from going between upstairs and downstairs. And that is true, but if the cornice is taking priority, then that's a natural compromise, and you have to look at it for what it is. The cornice itself is typically made from lime. So first of all, it has its own kind of resilience to things like condensation and mold. And second of all, it's quite thick by comparison to the wall plaster. So essentially it's kind of insulating in that zone already. So there are little ways in which you approach it, but most of the time you're just trying to rationalize, the compromise and make a case for keeping it in the first place, Yeah. But protected structures, you generally speaking, you don't have onerous U-value targets or anything like that. You're just working with what you have, and you're doing the best that you can in each given situation.
Yeah. Okay, there are just a few more questions here. SEI insists on U-values of 0.27 to avail of internal dry lining grant. Is there any intention to relax this for older buildings, as it is really pushing people into taking risks on older buildings?
I think
we mentioned that before the session. So there is a pilot scheme where they are looking at a relaxed HLI of 2.3. Now, I think it is only a pilot scheme. I don't think it has been launched. Oh, no, sorry, I don't think there's a target HLI on it. It is specifically for historic buildings. So I'd say maybe keep an eye on the websites, etc., and just see how that is progressing.
Yeah, absolutely. And I know just from speaking to people in the industry, so say ourselves, but you'd have people like Carrot Conservation and lots of others as well. I'm sure the BERAAI Assessors Association has come up with this as well several times, where they know instinctively it might be difficult on an older property to do that. So in turn, I can't imagine that they're not listening to this, because it's as you said, we've 500,000 homes to do. There's a real risk here that we might be retrofitting the retrofits. If we do it wrong in the first place, we might have to tackle it again further down the line. So there is a real risk, and as far as I know, there's quite a lot of lobbying going on, but I'm not sure exactly where that is. But the 0.27, all I'd say is just be careful, because it's generally agreed, and it has been agreed for a long time, and this doesn't come from me or Ecological Building Systems. This comes from like places that deal with historical monuments in Germany and Central European sources like the Fraunhofer and things like that. It's generally agreed, and it can be argued, because it depends on what you're dealing with, that U values in the territory of about 0.35 are approaching the limit of where you'd want to be pushing it. Now, is there a major difference between 0.35 and 0.27? It's in that realm, so you need to look at the capacity of the building to dry in that instance, so when you are going down to as low as 0.27, I'd certainly say you're on the limits, of risk, where risk starts to begin to become really prevalent, So if you're using things like plastics and foil boards and stuff like that, the risks are going to be higher again. So yeah, it's just worth being aware of it, really,
For sure. What is considered an adequate amount of ventilation to the exterior when using a dry lining internal wall system?
So the guidance from that,
10 millimeters.
Yeah, exactly. The guidance on that, it comes from BS 5250. I'm sure that code is correct, and it generally works out at about a 10 millimeter hole every half a meter, top and bottom, for the entire run of the dry line. If you work it out and if you calculate it, that's about what it looks like. So it's really significant in terms of perforating the building. And then what I don't like about it, so what I really dislike about that approach is it's very hard to quantify what's going on back there unless you've left probes in there, You're really relying on wind pressure differentials. So you're relying on, even if you do manage to do all them holes and you have nice, clever air bricks and things like that, if the wind is not blowing on a given day, you don't have any air change. If you don't get that pressure differential forcing air in and out, you're not getting air change in there. So I'd question, if you're not getting air change in there, what the hell's going on back there, you know? I personally don't like that. I've been working for Ecological Building Systems for 6 years. I probably worked on 2 dry lines, and both of them are really, you know, looked at very closely. For older buildings, now it's not. That's not to say that that's not suitable in cases where you have an insulated cavity and things like that. That's different, because you've got a warmer wall construction, you know. But just with old brick and stone, it makes me nervous looking at them, you know.
Yeah, I'll just take one more here, and it is in relation to major renovations. Have you been involved in any projects where an appeal was sent to the new building control office in Dublin Castle? And would you be able to explain how it was dealt with, and was there a good response, etc.?
You might just say that one once more.
In terms of Part L and major renovations, have you been involved in any projects where an appeal was sent to the new building control office in Dublin Castle? I
don't think so. I don't. So from our point of view, I guess it's more simple. You know, we're asked, we work closely with architects and things like that on specification, but then we might get asked at a later stage during the preliminary assessments for product documentation. And so long as we can demonstrate that we're in compliance with Part D, so are we CE marked, do we have DOPs? In other words, from that point of view, our requirements are completely fulfilled. Now, we might get some feedback loops at a later stage where a product was refused because it doesn't have IAB or something like that. Now, an appeal might be sent in, but I'm not actually sure where that would go from that point. It certainly wouldn't come back through me, you know.
Yeah.
But I'd be interested, because that would set a precedence. But what I can tell you is certainly, absolutely, without question, the HLI calculations, all of these materials we've covered today, every single one of them have been used in successful HLI applications. So where people are going for heat pump grants, and can they satisfy the HLI, and can they do it with this, that, and the other? Absolutely, yes. Whereas I think the little package that comes with the main grant for IWI, that's been a bit problematic. But it's not to say I don't know, because I haven't been involved in them all. I'm not sure who's done what, you know.
Yeah. Okay, look, we'll wrap it up at that. I think that